Hey, what's up everybody? This is Andrew Whitaker, and in this video I'll be showing you how to write an SEH exploit. I'll assume you already understand the basics of how structured exception handlers work and how the SEH exploits work. This exploit I'll be writing is against the Easy Chat server, which I'll launch. It's a very basic chat server application. It uses HTTP, and you just connect to it via this HTTP URL. And once you connect to it, you can log into various chat rooms and use various with the username and password. Now, the vulnerability is against the chat.ghp CGI script. If you pass an exploit or a very large buffer against either the username or the password, you can cause the application to crash. I'm going to take that information and knowing that a long username and password can cause it to crash, and see if I can do something a little bit more interesting with it. So I have here a kind of a skeleton of an exploit, and I'll walk you through kind of line by line what I have here. So we have here import string, import sys, import socket, import HTTP lib. These are just importing in various libraries. Particularly since I'm connecting to HTTP, I'm going to have the HTTP library here. And then I'm going to create this buffer. Now let me walk you through what I'm doing with this buffer here. I start out, I'm putting in 200 A's. Now, what I'm trying to do is I'm trying to override the exception handler entry on the stack. So I'm putting in 200 now. I know that 200 is not quite enough, but it's close. I'm doing this so you can see when it's not correct, and then later I'll show you when it is a correct value. Next, I'm just putting in some pattern here so that I can easily look on the stack and easily look within the exception handler or the SEH chain and see whether or not I am in fact overriding what the exception handler pointer address is. So I'm just using a pattern of dead beef because this is an Intel CPU and it requires the memory addresses to be put in little endian format. So I'm have to put in dead beef in reverse. So, but here we see the DE, AD, BE, EF. That's going to be followed up with 500 Bs or 42 in hex. And I'm just doing that. That later will be replaced with the shellcode. So for now, it's just kind of just a miscellaneous buffer that I'm going to later replace with my my shellcode. To for this demo, I'll be getting a command prompt. Now I create a variable called URL, and I'm going to assign that URL the chat.ghp username equals. This is the vulnerable CGI script, and for the username value, I'm going to put in my buffer. And then password equals, and then I'm going to put in my buffer again because the vulnerability exists with either a very large username or password. So I'm actually doing the exploit twice here. And then the CGI script requires you to specify which chat room you want, and whether or not you're male or female. So I'll just throw in and room equals 1 and sex equals 2. Printing to the screen that it's running. Now I'll create a new variable called con, and I'm assigning that con the results of the HTTP connection function. The HTTP connection function is part of the HTTP library here. And the parameters that I'm passing to this function is the IP address of the chat server, which happens to be this same this same system. I certainly could be launching this remotely though, and followed by the port number for the connection, which we're using the default HTTP port of 80. Now that we have our connection here, we're going to launch the request function, and we're going to do an HTTP GET request, and then we'll pass our URL. And then we'll create a new variable R1, which will store the results of the con.getResponse function. And then we'll print to the screen our status and our reason code. And to be a good programmer, we'll close off the HTTP connection. All right, let me go ahead and I'm going to launch Ollydbg, our debugger, so we can see how this exploit is going to affect the application. And I'll go up to the File menu and choose Attach, and find the Easy Chat server. And click Attach. And now that we have the application loaded up in Ollydbg, I'm going to go to a command prompt and I'll launch the exploit. Alright, so you can see we're passing to the GHP file a very long username of the A's, followed by the B's, and password, etc., followed by the @room equals 1 and sex equals 2. And if you go down into Ollydbg, down at the bottom left, it says access violation when writing to, etc. Use Shift F7 or F8 or F9 to pass the exception to the program. I'm going to go ahead and press Shift F7 to pass the exception so that now we can jump to that exception handler. Now I'm going to go up to the View menu and choose SEH chain. Our SEH chain is set to 42424242. Now, if you remember from the exploit, that is the 500 Bs. So 42 is the hex equivalent for Bs. So we haven't yet, we're trying to get this to equal the dead beef. So we're not quite at the right number. 200 bytes is not quite right. If I go back to this screen and we can look at the bottom right, we can see our stack. We drill down. You'll see all the A's, all the 41 A's. Then you see the pattern dead beef, followed by the 42s. And there we see the pointer to the next SEH record and then the SE handler. Notice that we're off. This SE handler is set to 42424242. We're trying to get it set to dead beef. So just to compare with a traditional stack-based overflow, you're trying to override the saved EIP value on a stack. With an SEH exploit, you're trying to override what that SE handler is. So I'm about 20 bytes off here if you were to count that up. So let me go back to my exploit and change this to 20 bytes and save it. And let me go back to Ollydbg and I'll restart it. And we'll press play. Get it all up and running. Go back, launch the exploit again. I'll press Shift F7 to pass the exception. We'll go up here to the view SEH chain, and now you'll notice that the SE handler has been overwritten with dead beef. So we now know the exact address, how many bytes we need to get to override the SE handler. Alright, so now we can start having fun. Now we can start creating our exploit. So let me get it set up and ready to go here. Alright, so we know that at 220 bytes we have the address to the for the exception handler. Okay. Remember though that every exception handler record has two parts. It starts with 4 bytes, that is a pointer to the next SEH, followed by another 4 bytes that is a pointer to the actual exception handler code. So I'm going to need to put in the pointer to the next SEH, which is 4 bytes before the pointer to the exception handler code. So I need to go back 4 bytes to 216. And now I need to put in what I want for my next SEH pointer. But rather than put in an actual memory address, I'm going to put in a machine instruction. I'm going to put in EB069090. Now EB is a short jump, and then 6 is the number of bytes we want to jump over. 90 is the machine instruction for a no op or no operation. It does absolutely nothing. I'm just putting in these 90s as padding. So what this whole instruction is going to do is going to do a short jump, 6 bytes. We're going to jump 1, 2, 3, 4, 5, 6 bytes, and that will land us into what I will into our shellcode. Later on, I'm going to replace these B's with the actual payload. What's great about this is you don't need a no-op sled, because with your short jump of 6 bytes, you jump and you land directly in with your shellcode. All right, so if you think about what's happening here, you're going 216 bytes to overflow the buffer. That's taking you to the pointer to the exception handler routine. What I need to do now is change this dead beef to equal a memory address that is going to take me to the next SEH. Once we get to the next SEH, we'll do our short jump and land into our shellcode. So what memory address will I use to get me to the next SEH? Well, I'm not going to pull it up right now, but if you were to look at the stack, what happens with the exception handler is you're just a few bytes off. So if you do a pop return instruction, you will pop 4 bytes off the stack, pop another 4 bytes off the stack, and then you will return at the next SEH within the exception handler structure. So if I can find in memory a pop return instruction, I can then jump to the next SEH, which will then make the short jump into our shellcode. So I need to search in memory for a pop return instruction. So what can I search? Well, I can search Windows DLLs, I can search application executables, and the easy chat server application executable, I should say, and the application DLLs. The issue is I can't use anything that has been compiled with SafeSEH.